science and upskilling in post-COVID-19 world. Okay. We have also Pawan with us. We're pleased to have him on this webinar. He is our speaker for the day. So hello, Pawan. Thanks for joining us. I don't think so we can hear you. Am I audible to you guys? Okay, so let me take this opportunity to introduce Pawan. Pawan Kumar is the head of data science and analytics at Uber. He is a data science leader and internet entrepreneur with more than 9 years of experience in building data-driven consumer markets for the hyper-local, social, and technology domains. He was one of the initial guys responsible for building LinkedIn's global mobile web platform. At LinkedIn India, he heads the product data science team where he is responsible for defining the strategy and execution and helps build great data-driven products for the next billion professionals. Prior to LinkedIn, he co-founded a music content sharing platform and advised many startups. So welcome to the session, Pawan. We are pleased to have you on board.
Thank you, Gaurav. Hi, everyone.
Yeah, I think your mic is sorted now. Okay, this is about me. My name is Gaurav Vadishain. I am the Vice President and Head of Data Science at LEARNXT, which is a part of SRM Group company. I have close to 10 years of experience working in data science machine learning projects. I have worked with multiple clients in India, Europe, and US. I have an MBA in marketing strategy from IIM Bangalore and a post-graduation in ML and AI from CMU, along with the engineering degree from KIT University. So let me set up the agenda for the day, and then we'll go through it. So we'll talk about LearnXt. I think it's very important to know from whom you're gonna hear. Pawan will help us to walk through analytics, what, why, and how. He'll talk about some of the real life case studies. He'll talk about some of the applications of analytics across domains and functions. He has actually, collated very interesting examples to give you a holistic view of applications of analytics across different verticals. We'll also talk about, I'll walk you through about some of the potential learning paths which you can take to enter into this field. So there's a very structured and streamlined approach by which you can become a data scientist. It's not a rocket science. It's fairly easy if you follow a right approach and right systems. And then we'll open it up for Q&A. So the first 45 minutes, we are going to walk you through with some of the insights, get you excited about, and I'm sure some of you are already excited about it, and that's why you have joined this session. But we'll get into deep dive of some of these applications, and then feel free to ask all the questions. I promise you at the end of the session, we'll be answering all the questions, whatever we see in the chat box. Okay, so in the first 5 minutes, let me brief about the company. So we are part of LearnXt. It's an SRM Group company. This is what we want to stand for: be more, achieve excellence in education. How can you really go ahead, learn something, and apply in your job roles? How can you learn some industry skills which would be relevant when you enter into the workforce of data science? We, as you say, we are a digital learning brand that helps people to achieve their dreams through education. This is what we stand for. We believe in physical age. We want to, have a blend of best of both. Bring all the physical education flavors along with the digital spheres. We have very flexible, portable, personalized learning platforms. The kind of programs what you're going to see, these are future relevant skills, which we call it as future skills in the word of NASCOM. And it has been designed with a very rigorous curriculum and content created and curated by our industry experts and academicians. We will have, with the COVID, coming into play, we will introduce some of the blended learning format, which will not compromise the quality of the education. In fact, it will enhance the quality of the education, and it will also enhance the experience to learn these new skills. Okay. These are some of our differentiators. We provide degree and diploma programs. Primarily, that's our USP. You will find a lot of certification programs in the industry. We do have two in that space, but primary focus is to impart degree and diploma programs. We have a very strong portfolio in data, business, and IT. We have extensive industry partnership integration. As I said, curriculum is aligned with certification bodies. It's conducted, delivered, and certified by SRM University. And we have in-house technology specialists with all domain understanding. And most of these programs are also outcome-based model. I think that is one thing which you will definitely ask about, at what will I get if I do this and that, right? So most of the programs comes with placement guarantee, and that's where we use the pedigree of the university to help you to get placed in different job roles. And as I mentioned about all the industry relevant tools are being covered in our reports. Some of our advantages, guaranteed placement, global faculties, very tight, comprehensive assessment plan and body, external industry certifications, and assistance guidance. This is a delivery framework. I'll not spend too much time on that, but yes, we have a flipped classroom model. We have hands-on labs. You'll be working on cloud-based labs. We have LMS, which is AI-enabled LMS, which will allow you to provide immersive, learning experience throughout the course. And obviously, with having the pedigree of the university, you will also have great alumni network and knowledge sharing sessions, gamified learning, and so on and so forth. Okay. SRM Group, many people know about it as an educational entity. So I wanted to take this slide to explain it. So yes, the primary forte is education, and LEARNXT is the digital arm of that division. But we have media, technology, hotels, transports, and other verticals also. This is how we are placed geographically in this country. You can see there are multiple campuses in Haryana, Sikkim. Everyone knows about Chennai campus. We have a campus in Andhra Pradesh, Amravati, and we have actually 3 campuses in Chennai, which you are seeing it here, and 4 campuses outside. This is about SRM Chennai, so I'm going to skip it. One of the well-known, India's top-ranked university, got multiple accolades, got multiple awards and aggregations from multiple industry bodies and academic bodies. This is a snapshot of what SRM stands for and what kind of students, what kind of courses, what kind of programs are being offered. And then we have it in Andhra Pradesh with different disciplines. Then we have it in Sonipat. Sorry. And then some of the international partnerships. This will, mostly with international universities that will allow you obviously to get the global exposure for any course what you pick up with SRM. Okay. This is a question which you're going to park it as of now. Is a degree in analytics worth it? Okay, and we'll come back to this question maybe 30 minutes after 30 minutes or so. Now, over to you, Pawan. You can explain us about the data science and as a field to us.
Sure. Thank you, Gaurav. This is great. Hi, everyone. Very good evening. And if people are joining from outside of India, very good morning. Right, whatever time zones you're in, I really appreciate that you're taking our time to kind of go through this course or the session. We're briefly going to be talking about what data science is all about. Why are we talking about data science in the first place? What are we going to do with data science? Where can it be used? How do we become a data scientist? And who can become a data scientist in reality, right? So we're going to cover some breadth of why, where, what, how, and who, right? And I want to keep the session very fluidic, very interactive, right? So if at any point in time, if you have questions, it's useful to kind of put it on chat or just unmute yourself, and then we could take a question from you directly, or we could also do Q&A towards the end, right? Just feel free to use this time to kind of also learn, right? So of course we've designed this in a sense to kind of give you an insight into what is data science, why is data science super powerful, how to become data scientist. But if you have questions that could basically want more depth, really happy to kind of discuss this during the course of the session or towards the end of it, right? So let's just quickly dig deeper into data science, the entire overview. I'm going to be talking about three main functions, right? I'm sure you've heard about this, right? So data science, there's a lot of excitement with data science and analytics. I mean, it's become one of the buzzwords in the country right now, and not only the country, right? I mean, globally, everybody is just talking about data science. If if you're on Facebook, if you're on Instagram, if you're on any product, any social product, you're often or not hit by a data science course, right? Somebody or the other is saying, why didn't you do the certification? Why didn't you pick up data science as a profession? Data science is also promised to basically give you a higher salary outfit, right? So there's a lot of excitement. Why is there all of this excitement, right? So we'll talk about some history, some of the latest example, and where does all of this come from, and what really is analytics and data science. I mean, how do you actually become a great analyst? And there's also another topic that we could cover at a later point in time, is to like, how do you become a data scientist at a top multinational company, right? And we can go through that. Next slide, please. Next one. Thanks. Right, a bit of a history, right? Data science is actually not new. It's just become all the more important in the modern world. But data science, as a matter of fact, has existed for a really, really long time, right? It all started off in 1935, when Fisher kind of designed an experiment to figure out the taste of the tea, right? It all started off then, right? So experiments, statistical experiments, began in 1935. Let me give you a brief history, right? So at this point, Fisher was testing with a lady, to figure out, there are two types of tea, right? So a tea that's actually made with milk added first and then tea added later. The other variant was where you added the tea first. I mean, you added tea in the boiling water and then added milk later, right? So he wanted to kind of statistically prove, is it possible for you to identify? Uh, Hi, is there a question? Sorry. Okay, so just moving on, right? So identify if you can differentiate, right, between which tea was actually with milk first or with tea first, right? So he designed a very, very thoughtful experiment, right? So where he basically gave eight cups of tea, in which in 4 cups you had milk added first, and the next 4 cups you actually had tea added first, and then he arranged them in a random order, and he gave it to a lady to kind of test, right? And the end objective was, he's the guy who actually coined the term null hypothesis, right? So we're going to talk about what null hypothesis is at much later time, right? And to predict the chance of, you predict the ability to predict, which tea is which, right? And this prediction shouldn't have been based on chance, but based on a probability, right? So that was 1935 when he actually first designed that experiment and coined the term null hypothesis, which is something that we use in our day-to-day world today, right? And then of course in 1939, you actually have Shewhart, who actually designed a quality control system, which is actually used even today in telecom industries, to actually intelligently use data to switch the network so that it becomes reliable. He was actually part of the Bell telephone company, and he designed the first quality control system for a telecom operator at that point. And then you of course know about a business intelligence system at 1958 that IBM designed, right? This was all based on data. And then Google started. The entire product that Google had was just completely data-driven product, right? So we'll talk about what that was, right? So just in later slides. And then in 2007, there's an author who actually defined data to be the fourth paradigm, right? What does that mean, right? So there is computation is one of the paradigm, right? Data is another paradigm. Then operational excellence is another paradigm, right? So it became all the more important. And in 1978 is when exploratory data analysis actually started taking form, right? And then there are many examples, right? So this is a timeline. A brief sense is, data is not new to us. Data has always existed. It's just that the application of data is something that we are kind of like using more often right now. And some of the genius who kind of figured this out very, very, very early on, started, went on to do really, really big things, right? That's the power of data. And let's kind of now dig in a little deeper and figure out, how is this transforming the world, right? Next slide, please. right? Think about the modern day, right? I mean, there are of course, how are we using this data? Think about what all can you do with this data. Today, you could actually predict a flu's trend using some of the historical data. We in fact predicted the outbreak of COVID, right? Even before it happened, right? We actually estimated how many people will be infected by what time, right? You saw that happen in the US, you saw that happen in India, you saw that happen in, various parts of the country, right? How are we so prepared, right? So what advantage did this give us, right? It helped us become more prepared. We knew what the control was. Now, how did you actually get some of this data, right? There's historically, some data that's been captured for flus, right? So there is also predictive data, right? So you take a sample of people, right? So what happened very early on is that, we picked up a sample of people that got infected, and we analyzed that area, right? When you actually induced, three or four people in a community, right? How long did it take for them to infect the next 500 people or the next community, right? You took that estimate and kind of like scaled it outside, right? It's a very, very complex mathematical model, but it's doable, right? It's doable only because we have the data, we have computational power, and we'll kind of explore that, right? So think about, Google gave you a prediction. There was you had Microsoft tool that was predicting, how is your COVID rate growing. You had Google tools that were predicting. You had, like, economists, you had like statisticians who were actually predicting, when are we going to hit the peak, right? I mean, there was this lot of things that said, October is going to be our peak, right? And it did happen, right? September and October, close to September, October is where we saw the peak, right? In some sense. So data is, it's also exciting because not only are you in an ability to kind of use data, but you're also able to effectively use data to predict the future outcomes and help you get prepared, right? So that, can you move on to the next slide? Hey, Gaurav, I see you on the screen. Yeah, right. So it just doesn't stop with that, right? Did you hear about the Cambridge Analytica fiasco, in terms of, like, what happened with the recent US election, Indian election, and in fact even like the 2012 Obama election, right? They started leveraging so much data to actually influence you to vote in one direction, right? That's the power of data. I mean, today we are leveraging data for everything. The length of breadth of where data and how data is being useful and effective. It's not only in industries, right? It's not only in banking. It's not only to keep your credit card statements. It's not only to keep your, Facebook running. People are using data to kind of, have a very political agenda. People are using data for, predicting flus, predicting, COVID. People are using data for elections purposes, right? Data has become so powerful, and the things that you can do with this data is, I mean, sky is the only limit, right? And we'll dig a little deeper. The reason why I bought in the 2012 election was, like, Obama actually collected, close to 4.5 million people's worth of data and their entire friends cohort, right? To basically, engage with them, and to also convert them to start voting for a new change, for a new transformation. And similarly, India's gone through a very similar process. Recent Cambridge Analytica fiasco, what happened in the US election, right? So data has become so powerful. All right. Next slide, please. Right. So here is, some data which basically talks about that political election, right? So, one of the several ways that Mr. Obama's campaign was actually successful is because, they started, hiring behavioral scientists, data scientists, who actually set up this infrastructure to start collecting, people's data, collecting people who are inclined towards Obama, people who are not inclined towards Obama's campaign, and people who are in between, who you can basically change the attributes, change the behavior, and, make them kind of vote towards that, right? So it's a very, very powerful use case in terms of, how you can leverage data, not only to do, really bring in positive effects, but, if this goes into the wrong hands, I mean, if you start using data in a very negative connotation, I mean, it could also kind of harm the ecosystem, right? And, data becomes so prevalent that in 2015 the US government in fact named a chief data scientist at the White House, right? That's the pinnacle when data actually hit. I mean, you have a data scientist, sitting out of White House, right? That should tell you how important data has become in today's world, right? It's actually part of a White House campaign. I mean, nobody has ever thought about it, nobody ever even imagined. And here we have our own DJ Patil, who ended up becoming the chief data scientist, right, for the White House. And now he's, of course, I had the pleasure of meeting him, and he's, of course, doing something with the healthcare. Now let's look at some of the other applications, right, so that you can relate to, right, apart from just political campaign. Have you ever seen, I'm sure like you've seen, sponsored ads coming on Google, right, on the right hand side. This is a very, very old, right, interface of Google. Do you see, what's happening on the right hand side in terms of sponsored links? You see they've shown a towel bar. You've seen somebody showing a towel rack, right? How does that happen? How do they know what to show you, right? What are the different products that you're exploring? I'm sure like you've experienced this. You search some website, and all of a sudden, you're on you visited certain website, and suddenly on Facebook, you start seeing ads about that product, right? Has this happened to you? They're mining so much data about what you do, that now even the ad personalization is super valuable. And this has now become such a big industry. Gaurav, can we go to the next slide? Right. $50 billion in revenue just coming in from ad targeting. Just imagine, how much of data is being leveraged, so that today some of the ads are so contextual in nature, you just don't mind them being there, right? Because it's not like they're out of context, right? That's how products have evolved, right? So sponsored search in Google now also uses an auction platform for marketers to actually try and win access to customers, right? Now, how do they basically do that? There is so much data available, right? How do I show you? At any point in time, one user is interested in multiple things, right? So they've kind of created a very data-driven product there. There are about 30 billion search requests a month, right? That's huge. Just imagine 30 billion search requests and 30 billion or more, sponsored ads that's actually been shown to you in real time. And they don't show you ads that are very, very historical in nature, right? You must have seen, sometimes when you have finished buying a car, all of a sudden the car ads have just vanished, right? Has that ever happened to you? And when you're exploring to buy a car or a bike, everywhere that you turn, you're seeing the bike ads, the car ads, right? All of that is possible only because of data, right? And this is how data is being mined and used for in some of these industries to actually drive revenue for them. It's in the core of what the company does. I mean, today Google can't exist if we don't have that data. There's nothing. I mean, what is Google end of the day, right? What did they do early in the 1997? What did they do? Right, can you go to the next slide, Gaurav? Right? We'll talk about this. Sorry. In 1997, they came up with this product called BlackRock. All right. What was it all about? All right. They scanned pages and pages of books and articles and links and everything. They converted into a digital format and stored it. All right. And they indexed it. That data is what is getting leveraged today. And of course, it's kind of like increased multifold. At the core of it, right, the entire Google search engine is just a data driven product, right? Yeah, there is a saying in our industry, right? There are of course engineers, there are scientists, and there are scientists who actually there are of course scientists outside of Google, there are scientists inside of Google, and there are scientists inside of Google search, right? The scientists inside of Google search who was responsible for search are like pinnacle, right? What they do and what they basically bring out is unimaginable, right? The complexity which that they work with and the outputs that you see is very magical, right? In some sense, right? And that's how much power data basically has. And if you kind of look at the evolving industry of data and analytics, very, very early on in the 1980s to 1990s, it was all about data warehousing, right? Can I start collecting some amount of data? This is where, companies like IBM and everybody were like into, can I start collecting some amount of data? Minimal data collection was happening, right? And then, fast forward yourself into the 2000s, we were now, getting into business intelligence. This was an era where data reporting had become such a big thing, right? This was an era where Tableau and some of the dashboards that we have kind of like peaked, all right? And then we went into performance management, right? So performance management is where we started literally leveraging data to actually make some business sense, all right? 2010 and 2015 is all about, complex analytics, right? Today you're not only able to predict what's happening, you're analyzing, you're changing how products should look like, you're changing, how Facebook should look like. I'll give you an example, right? 2020 to 2015, right? If you remember, very early on, Facebook just had one like button, right? Today it has a button called reaction, where you can actually express heart, where you can actually express LOL, right? Laughing out loud. How did that come to happen? Right, I'll talk to you about it, right? It's a completely data driven product, right? Nobody thought about it, right? All of this actually emerged using their data. So Facebook actually started mining the comment section, right? They started looking at, what are people commenting, what are the popular emojis that are there in the comments, right? Then they basically used that data, ranked, scored, standardized, and figured out, these are the 5 most popular emojis that people use, right? And they converted that into a reaction product, right? Just a very, very simple example of how effective, data is. They started mining just their comments data, and they came up with a new product that's called reaction. And reaction's been very, very successful at Facebook, right? Because at the core we all understand that when my mom is posting something, I just don't want to like, I want to basically share a heart, right? But when I'm when I see a post that is not really to my taste, I don't want to basically react at all, right? Or probably have speechless. When there is a really funny post that's happening, I really want to express laughing out loud, right? Different emotions that they're bringing in onto the product, right? And how did that come about, right? Who thought about it? Who thought about what are those 5 reactions that needs to go in, right? Why couldn't they have unlike or dislike, right? Why couldn't they have like a crying emoji or some other emoji? There are tons of emojis out there, right? Why did they shortlist 5? How did they come over that 5 as a number, right? There is a bit of a history to it, right? So this is where data is actually helping, right? Some of these companies make some of these innovative data products, innovative solutions that's actually propelling their business, right? And now today in this world, you're all talking about artificial intelligence, machine learning. 2015 and above, everything is all about artificial intelligence, autonomous cars, and there's machine learning products. Everything is a recommendation engine. How your e-commerce is working, how your social media is working. In fact, there is so much of machine learning in some of your cars that you're driving, in some of the bikes that you're driving today, right? So that you're not realizing, and how your phones are working, the pictures that you take all have AI engine that are basically running to kind of give you the perfect picture that you like, right? And of course there's the entire AI engine running to give you the right feed on Facebook, right? The right content on any learning platform, right? The right videos on YouTube, right? And so on and so forth, right? So this is kind of like how the entire evolution has happened. And today, yes, there are 2 things that you need to keep in mind, right? In this era, business analytics, AI, and machine learning are the 3 big keywords that you really need to optimize, right? That's why I've kind of like drawn that line. Today, the focus is on these 2 areas. All right. One is the entire analytics engine. And I give you an example, how Facebook is using analytics to kind of create data products. And the second is completely artificial intelligence. Can I basically create a reinforcement model that is learning and kind of like giving me personalization, right? These are, two big keywords or buzzwords or 2 big industries and domain that we are into today, right? And there's going to be a lot of focus on this for the next 5 to 10 years. All right. Next slide, please. Right, here is a very, very interesting slide, right? So we kind of like researched and bought this slide. When people went around doing a survey and asking within an organization, what are the most skill gaps that we have, 44% of people in a company, right, went about saying they lack data science people, right? They need data science. The 44% of people in a company, right? 44% of your leadership team are saying, we need more data scientists, right? 41% is saying we need more data engineering, right? Then we need more data visualization people. We need more storytellers. Visualization and storytellers are like, people who can, convert an analysis and narrate a story and then kind of say, right? See the importance of data. Look at that chart, right? If a 50% of your company is actually saying, close to 50% is saying, we need more data scientists, it only says that data science is going to evolve further. There are going to be more and more data science opportunities in the future. And as of today, what's been estimated is in the next 1 2 years, US alone, I'm not even talking about India, all right? US alone is going to be short of 1.5 million data scientists, right? That is the amount of skill gap that we have in terms of people, who should be data scientists or data analyst. And think about, we are moving into an ecosystem which is an always on ecosystem. There is so much amount of data that's being collected. I mean, your Android phones is, logging every moment, every location, your GPS, your traffic, your, whatever you're browsing, your WhatsApp, your Facebook, you're on tons of digital product today, including Zoom, right? Including the session, right? Imagine the amount of data that we are producing per person. It's estimated that per person is producing 1.5 MB worth of personal data every second, right? That's the amount of data that is getting produced. But do we have enough people to mine that data and to, convert that data into meaningful insights, right? We don't. We lack them. And I'll give you my own personal experience. I've been hiring for LinkedIn and now at Uber for the last 5 years, and we've been struggling to hire data scientists, right? There is a big shortage of data scientists, right? Good data scientists, right? I mean, there are of course a lot of people who say data scientist, but they don't meet the bar, right? We actually lack good data scientists to come in, right? Next slide, please. Right. What is analytics all about? I mean, we spoke about, why do we have so much of excitement in data scientists, and why is data science as a profession or a domain really important, right? Just because of the entire skill gap that we spoke about, right? There's going to be more and more data science jobs that are going to get created just because of the volume of data that we're producing today, and in the next 5 years is going to be like rapidly increasing, exponentially growing. We need more people to come in to kind of solve that problem, to even break that data down and to meaningfully convert that into insights, right? Now, let's assume we understand data science is going to last, right? It's going to be the hottest profession for the next 10 to 15 years, right? And then we might actually take shapes and form to kind of evolve into a different form using data, right? But what do you do? Who's a good data scientist, right? What is a data scientist is supposed to kind of do when he comes in, right? I've kind of broken this down into 4 things, right? Very at a very higher level, and then we can go in depth, right? One is, with all of this data that you have, right, one of the key roles that you're going to be playing is understand customer behavior, right? What does customer behavior mean, right? Let's take this example of an e-commerce site, right? Who's actually buying what product, right? Not everybody is buying a phone, right? Somebody is buying a washing machine, somebody is buying a phone, somebody is buying a furniture, somebody is buying clothing, right? How are they buying, right? What is their pattern, right? Are they buying via COD? Are they buying via cash? Are they buying via credit cards? How many products do they buy, right? What kind of segmentations do you have, right? So there are also people, um, people who are entitled to a subscription, or like, for example, people who can interact with a campaign, and people who cannot interact with a campaign, right? There are all sorts of customer behavior that we can mine, right? So saying, can I basically say a user is going to click on this campaign, right? Let's say Flipkart is coming up with Big Billion Days. Who should I target, right? Can I target this user with a TV ad, right? Today, I mean, you could see, like, you will get a bunch of emails. Some people are getting TV ads, some people are getting mobile, some people are getting clothing. Like recently, my if I look at my social media versus my email versus post to my wife's, right? The products that we get from the same company, like Flipkart has sent out an email, the kind of products that they've shown me versus the kind of product that they've shown her is completely different, right? Why and how, right? And it's so contextual, right? They actually showed her a lot of cosmetic products, right? And then she clicked on it and bought it, right? As opposed to me, they showed a bunch of, like, men's grooming product and phones and so on and so forth, which I still didn't end up buying, but that's for another day, right? So how are they able to distinguish this? These are customer behaviors that they're mining and kind of like driving an application. Now let's look at the second thing that you're going to do is product usage, right? Let's take Uber for an example, right? So what does product usage mean, right? How often are you using the product, right? How often are you taking a trip, right? Let's take LinkedIn, for example, or Facebook, for example, right? What are the different things that you do when you come onto LinkedIn or Facebook? Do you like a content? Do you share? Do you comment? What type of content are you liking, right? Can I show you more content that are similar, right? What is your session length, right? Session in this case is like how long do you spend on that platform? Do you search more often? Do you scroll more often? Do you connect with people more often? Do you make friends more often, right? They're trying to understand that product, right? And one of the examples that I gave you is based on the product uses, Facebook actually came up with that reaction button, right? So simple as that, right? So that's one of the things that you're going to be doing, right? So you're going to leverage the data that you have, and you're going to come up with, what features should we do, right? And then there is of course business model innovation, right? Likewise, like for example, I'll talk about Uber, right? We looked at the data, we looked at what's happening with Uber. There's tons of people who are using Uber, right? But we figured out there is a subset of population that can't access Uber, right? Just because they're on low end Android phones, right? And some of this complex technologies require, like running a map requires high end applications, high end phone. It's very efficient only when on a good phone, but if you're using a very very low end device, right, you will not see great experience, right? So we figured out, if we want to attract a tier 2 tier 3 people onto a platform who are now on low end Android devices, but our application that we've designed is not for them, that basically gives us, you look at that data, and that basically gives us a chance to kind of innovate again, right? Come up with new products. Like you must have seen Flipkart launch Flipkart Lite, right? Facebook launched Facebook Lite, right? Why did they launch Facebook Lite? That's an innovation, right? Because they kind of like understood, hey, my product is actually not reaching everybody, right? For it to reach everybody, what should we do, right? They understood that, hey, there are a huge set of people who are coming onto your platform, but they're not able to access everything because of low internet connectivity, because of low phone, a bunch of gaps in the product. And they said, for me to basically tackle this problem, I need to have a very lightweight app, right? Which is lighter, faster, right? Facebook Lite, when they launched Facebook Lite in about 3 months, it grew from 0 to 2 million downloads in about 2 months, right? That is called business model innovation, right? You use that data to find out, saying, they went about looking at it, and they said, India, there is a significant portion of people who are not able to access Facebook. But if we had this product, they will access Facebook. They built that product, they increase access, right? Increase operational efficiencies, right? If you think about companies like telecom industries, right? The switching algorithms, how do you switch between networks? How do you very smoothly go from 4G, 3G, 2G? When instead of dropping the network from 4G to 0, they've also kind of like included data to kind of switch between different efficiencies, different methods, right? You must have seen that happen, right? And how do you flawlessly on the phone, when you have a Wi-Fi and Wi-Fi drops, you move into 4G, right? How smoothly that happens, right? How are they able to do that? They're actually using data to kind of predict, right, and improve operational efficiencies, right? You must have seen this on Chrome, right? When you close Chrome and open Chrome again, right, your tabs are restored. Why and how, right? They're storing that information. Data is actually being very very powerful, and today you can't live without Chrome or Google Chrome kind of not recommending what are the previous tabs that you opened, right? And so on, right? So these broadly, how you can leverage data to kind of solve problems for different industries in a different application, and these are some of the use cases. Next slide, please. Right. So let's talk about what the hierarchy looks like. The people talking about, there's ML model, there is analytics, there is reporting, there is dashboarding. I'm sure like you must have heard about, some of these keywords. Let's kind of like put like a value chart in terms of, where do people sit, right? Or what happens, right? So if you look at it, the first layer is called the big data layer, where people are actually sitting and creating data, who are capturing data. Like for example, if you take Facebook or LinkedIn, for example, right? Every time you kind of scroll through a content, every time you like something, right? So data is getting generated, right? Every time you kind of comment on it, that is getting captured. Now that data needs to be streamlined and captured in some database, right? So the first layer is, data engineering people who actually, capture this heterogeneous data, right? And then store it in, some form, right? The next layer is they they take all of this streaming data. Now we can talk about, what is the streaming data and all of this. I mean, we get a little more technical, but maybe for another round, right? So just imagine that, there is this collection of data that is happening based on whatever you're doing on the platform. And then there is the second team, which is responsible for converting and cleaning up that data, right? And then, creating a structure, right? So this is a layer where you have data engineers and ETL engineers coming into the picture, right? The first two layers are, engineering driven, very data infrastructure, data engineering driven. The next layer is kind of the reporting infrastructure, right? So these are mostly, analysts, BI. You must have heard about, business intelligence, right? BI analysts, right? So these are the guys who actually create dashboards, right? So that, the CEO, the company can actually monitor, how many people are visiting Facebook today, how many people are liking today, right? How many people are searching today, right? How many people actually got a job today at LinkedIn, right? How many people are applying for a job today at LinkedIn, right? So these are actually, dashboards that basically help capture some of the business insights, some of the business metrics, right? So at Uber, we start capturing things like, how many rides, how many trips did somebody take today, right? In a week, how many trips are happening, and so on and so forth, right? And then there is this analytics layer, which is, data scientists and data analysts, where we come in to actually do two. There are actually three types of analytics, but anyways, we'll talk about two for now, which is mostly used, all right? Prescriptive and predictive, right? Predictive, I'm sure you already know what predictive is, right? Predictive, as the name suggests, you're predicting something is going to happen. Like how you predicted what is the peak of COVID, right? Like how you can predict, if this customer is going to buy this product or not, right? How you can predict, if a user is going to uninstall the app or not, right? How you start predicting, some of this promotion offer to a person. Have you ever imagined suddenly, you've been targeted with a promotion for a product? You have installed an app, you've not used it, and very closely you're thinking of uninstalling an app, and you almost realize there is a campaign that's saying, hey, 20% off on Flipkart for you, or Myntra, 70% off, up to 70% on Myntra, right? Which is very, very personalized. And then you basically explore, and then you stay, right? And then you don't uninstall, right? You're predicting the future outcomes, right? Prescriptive is, I give you an example of what Facebook did with the reactions icon, right? Which is more prescriptive kind of work, all right? So these are different forms of work that we take up in analytics and data science as a vertical, right? Next slide, please. Right. So let's give you an overall understanding of, what is the life cycle, right? So when you join a company as data analyst or data scientist or business analyst, what are the things that you are expected to go through? I think one of the things that we today really focus on is 5, 6, and 7. I put up numbers, we'll talk about it. The first thing that we talk about is like, I want to build a model, right? I want to build like a machine learning model. I want to analyze the data, right? I want to deploy something. No, that's not where it starts. The journey actually starts, right? So this is something really, really useful to keep in mind. This is a very, very powerful slide, right? Going to be super useful as and when you kind of finish the course and enter into the job market, right? First is understanding what is the business need, right? Stating where the problem is, right? So let's take this for an example, right? So in my journey, when LinkedIn wanted to kind of build a LinkedIn Lite app. Okay, so LinkedIn Lite is nothing but faster and lighter form of LinkedIn app, right? Which was just 1 MB in size and could load information 6x faster, right? So somebody came up with this idea saying, we want to build LinkedIn Lite, right? Because we want to provide more access to people, right? Um, Now, first thing as a data scientist or an analyst is like, hey, is there even a problem? Why do we believe that we need a lighter platform? Like, for example, I could basically give you a rationale saying people who use LinkedIn are already in a job, right? Who are, senior professionals mostly, right? So, when they're already a professional entity, they all have good phones, they have good bandwidth, they have good internet, we don't need to build it, right? It starts with that. As data scientist, you are the guy who are actually talking to the business and saying, is there even a problem? It's a good idea, but should LinkedIn build it? I don't know if LinkedIn has a use case to build it. You start looking at it. The second is the first is that question, right? And then you explore with the data that you have, saying, does this problem really exist? You go about looking for data, saying, what, how many people actually tried accessing LinkedIn but didn't access, or just dropped off, or the wait time to load that page was like longer. Like for example, I'll tell you, in one of the page LinkedIn pages, the home page, for some people in tier 2, tier 3 cities, it would just not load, right? We saw a significant portion of people who had teething problem with loading the application, right? People who would try and install the app but not open and uninstall the app, right, just because they were on lower devices. The second is we actually identified there is a huge cohort of people who need this, right? Next is try and understand more about this use case, right? Do we have the data? The third question is, I think you should ask the company or the business or the product that you're working with, do we even have this data internally to even identify if this problem exists, right? So for example, at LinkedIn, if we wanted to solve this problem, I wanted to know how many people actually were using LinkedIn on low end phones, right? So today I know that you're on Android or on iOS, right? iOS is a different entity. Let's leave them apart, right? Let's talk about Android, right? How many of them are actually using a phone that has low storage, low memory, right? How many actually have like 2 GB storage or less than 2 GB of RAM, right? Or 6 GB storage, right? How many of those users? We didn't have that data, right? So what we had was, some device level data, and we had to actually go and procure that data externally and map, some of those device. So we basically have like some ID like Samsung SH003, some model number, and then we basically procured more data and mapped that Samsung SH003 means it's a device with 2 GB of memory, 4 GB of storage. It's running a quad core processor and so on and so forth, right? And we looked at, when we combined the data, we actually had a much deeper understanding of what that product, how many people are actually using our product in lower end devices that are actually not getting fulfilled or served, right? So we collected more additional data, and then we established a clear data point saying there is a gap, right? Then comes, then you prepare, who are you building this for, right? Are you building this light for everybody, right? No, right? You're building this for a subset of audience, right? So what should you build, right? What are they looking for when you're trying to build a lighter platform? What are they looking for? They're not looking to message anybody, right? So the intent is, they're coming in to find a job, right? They're coming in very, very transactionally, right? So they're commuting and they want to basically access LinkedIn quickly to check somebody's profile, or to check for a job, or to be connected in an industry, right? So they quickly take a look at that, right? So what should be the product? What should the product look like, right? It should basically be lighter and faster for these scenarios, right? So what should we focus on, right? So we start preparing that data, and then you start analyzing. The fifth step is analyzing. Now this is where your analytics actually come to the place. Of course, analytics is happening across the board, right? The fifth place is where analysis happens. Now in this analysis, you're saying, hey, I don't want search, right? Because people don't search on the mobile web platform as much, right? We can have a very, very simplified search, right? People don't search for content. People only search for people, or people search for jobs, right? Why do we have hashtag search? Why do we have other search? Why do we have post search? Why do we have all this complicated search that is not required for the lighter platform? All right. Let's give them the product that they're wanting to use. Let's make that experience faster. Let's make that experience lighter. So we removed all that junk search, right, for these cohort of users. And we had tons of feed item. When you're on the home page, you see like different posts, different popular in an industry, and so on and so forth. Right. So do we need all of them? Maybe not, right? For people who are accessing this product in tier 2 and tier 3 cities, they don't need all of this information. Let's give them the information that they really want to. All right. So you kind of like thin and skin down the entire feed. I mean, we actually removed 50% of the feed. All right. And then you looked at job experience, what type of job experience, what should be displayed, right? So on and so forth, right? I mean, I'm sure you've kind of like experienced it. So that happens. And then you start visualizing it, reporting it, and then you start experimenting, which is your 6 and 7, right? So then you deploy the solutions, right? So one of the things that we also did using analysis is, hey, not everything is a very engineering driven solution, right? Sometimes, what happens, how do you basically make the platform look faster? When you're actually on the homepage, we in fact predict what is your next move going to be. Are you going to search? Are you going to the jobs tab? Are you going to basically connect with somebody? And we prefetch it while you're on stage 1. While you're just browsing on the homepage, we actually prefetch what you're going to do next and store it in your mobile device. And when you tap, boop, right, it opens up. it almost seems like it's instantaneous, right? But there's a lot of data background happening there, right? Somebody has actually written this predictive module to say, hey, Pawan's next action is going to be, he's going to search for a job, right? And we should have the search module kind of already pulled in, right? So just imagine, I mean, even in terms of how you design the product, right? How much of data is getting used, right? We can in fact like predict what your next move is, and then create that experience seamlessly, right? So this entire journey, right, is what happens in a big tech company, right? So they go through from identifying a problem, then creating evidence saying that problem actually exists, then exploring more data and saying, who are we trying to solve this problem, what should the product look like, what should the solution look like, and then finally go through this entire analytics life cycle, right? So that's the entire journey, right, of how analytics is looked at. I mean, don't look at analytics as, I'm here, I'm going to like build a model and then just done with it, right? Analytics and data science is just not about just building models. It's about asking the right question, defining the right problem, identifying who are you building the solution for, how are you building that, and that entire journey, right? It's a very, very interesting and exciting space. Like, you in some sense are the problem solver, right? You are a problem solver with not gut, with not an opinion, but facts, right? That's a very, very powerful seat to be in, right? Today, my experience, okay, we'll talk about my experience a little later, right? What are the outcomes, right? When you talk about data science, there are only a few things that you've heard, but let's kind of go through, what are all the things, what are all the outcomes that you will drive as an individual that you can be proud of, right? You could end up creating a prediction model, right? You can predict what the value is, who's going to uninstall the app. You can predict, what movies is Pawan likely to watch on Netflix, right? There is a classification problem. I'm sure like you must have all used Gmail, right? Um, you know, Back in those days, we'd have this problem of spam. Today, Gmail by default classifies spam and non-spam, right? That's the classification problem. How is that happening? Data. A data scientist has actually built that, right? Recommendation systems, your Amazon, your Netflix of the world, right? So they're actually recommending things to buy, things to see, things to watch, right? Anomaly detection, right? I told you, fraud detections, your credit card frauds, right? So when somebody is trying to use your card, there are actually systems and tools which basically detect fraud, and we kind of block access, right? Your banking systems go through a lot of credit fraud detection systems, anomaly detections, right? Recognition, right? You're all talking about fingerprint sensor, face sensors. We are talking about face recognition, facial recognitions when you enter the airport right now, right? So if you actually go to China, I happen to have the opportunity to visit Alibaba at one point, right? Nobody's wearing an ID card there. Everything's on face detection. They're walking into the office and exiting the office. The gates actually open up. It's all happening seamlessly. And there are like 20 people behind me who are also trying to enter the gate. And it kind of like detects who's kind of entering and going in, right? So just imagine the recognition, right? There's audio, there's video, there's facial, there's text, there's all sorts of things. There's computer vision is a new upcoming field, right? Which is actually getting used in autonomous driving, right? Then there's insights generation, which we spoke about, right? About the Facebook example on reactions that we told about, right? Visualization, reports, analytics, right? And then there's scoring and ranking, which is actually used in bankings, right? Have you ever imagined why some banks actually, not give some people loans? Why some banks actually give some people loans? There is a credit score. How do they compute that credit score, right? There is a scoring algorithm that somebody has actually written, right? There's segmenting. Like we spoke about the Flipkart example, the Myntra example, in terms of my wife started seeing a lot of cosmetic related products. I started seeing a lot of electronic related products, right? So how does that happen, right? That segmentation, right, for marketing. And then there's optimization and forecast. Forecast is what your COVID example, right? So we spoke about we're able to predict in the future, right? So most companies today can also predict what is the expected amount of traffic on their platform tomorrow, right? I'm not even kidding, right? So at Uber, we'll know to a certain degree, right, what is the number of rides that we are going to have on the platform tomorrow, right? And if our forecast basically says it's going to be lower than what it should be, right, there is a high alert, right? And if the actuals are lower than the forecast, there's actually a high alert. That kind of gives us a system to kind of like figure out, hey, what went wrong, and be very proactive in some sense to arrest the decline, right? So just imagine the kind of kind of applications that we can build using data into companies, into industries, your bus prediction, like if you're wanting to kind of like work on government and policies and so on and so forth, detecting earthquakes, detecting weather changes, right? NASA is detecting which planet is going to cross, right? When are they going to come in, right? So it's all data, right? There's all data and science, right? So next slide, please. Right, so let's now, so now we understood how powerful data is, what are the different applications that you can do with data, right? So let me walk you through my own experience in terms of what we do at LinkedIn and Uber. Just before that, I want to basically narrate, give you a quick overview into my journey, right? I'm sure most of you might also have this question in your head saying, how can I become a data scientist? What is the background that I need, right? Let me tell you who I am, right? I am not from an IIT. I am not from IIM. I'm a regular, VTU engineering candidate who actually did, who actually acquired nominal grades. I was not even like excellent in my schooling, in my college, nothing, right? I was interested in a few things, and I was interested in being very analytical, being very logical. I'd have this experience of learning, start using data very early on, right? Stumbled upon, we were trying to solve this. I was a musician in college. I was wanting to kind of understand, people have different tastes in music, right? How does that work, right? Is there a way that we could predict who likes what, right? So very early on, there was this lot of curiosity question, and without having to go through that background, and not from an IIT or an IIM background, I slowly did a lot of things, learned, self-built, took up a lot of courses, signed up a lot of certification, and ended up becoming a data scientist. And I've grown to now head data science for Uber India, right? So if I can do it, so can all of you, right? It doesn't necessarily require rocket science. It doesn't necessarily require you to be born with a certain ability or a skill set. All of this, there is a process to it. As long as you follow that process, as long as you are disciplined to kind of go through that journey in a very systematic way, right? You could all be great data scientists or great data analysts, right? And speaking for myself, based on the last 5 to 6 years of my hiring, right, we are short of good data scientists. And we spoke about a lot of things. There are of course much more that we need to talk about. These are really a field for you to look up to, work on, so that there is also a great upside in terms of the type of problem that you're going to be solving. It's a very exciting domain, and of course financially also it's a great domain to be in, right? And now let me talk about what we do at LinkedIn and Uber. What does a typical data scientist day looks like, right? Let me talk about my new company, right? So I just happened to join them as head of data science. What do we do at Uber? All right, so a typical day looks like, we look at the product. Right, we look at, let's talk about one part of the product. All right, let's talk about onboarding. All right, so what is an onboarding? All right, so this is where people install the Uber app, and then they basically give you phone number, then they add OTP, then they write email address, then password, then they basically add payment information, and then come to the booking, right? Right, booking thing, right? So this entire flow is called onboarding for us, right? So we look at, if there are 100 people who start onboarding, right? Do 100 people actually end up booking the trip? No, right? People drop off, right? People drop off for various reasons. People drop off because somebody didn't get an OTP on time, right? People drop off because their email verification didn't happen, or they didn't have a credit card information, right? You use all of this data, and Uber is actually designed in US, right, where everybody has a credit card. When Uber is launched in India, right, do you think it's going to work? It's not going to work, right? India doesn't even have credit card penetration, right? They have like probably 2% or 4% credit card penetration, right? So we need to change a lot of things for the local markets, right? So you analyze data and you change. So we start looking at, how many people are signing up, how many people are converting. Of the people who convert, how many people are booking a ride, right? What is the value of the ride? Is that experience great? Right? Did we upgrade that user from, let's say, a pool to a go, or from go to a premium, right? or an X, and so on and so forth, right? And then we're building, shortest route algorithms. We're looking at, shared ride, the Uber pool model, right? How do you basically know that, what are the different people that you should pick up? What is the best route for somebody to travel, right? So these are all things that we're doing. And of course, we're also looking at, who's not engaging on the app. What should we do? Is there a promotion that we can run to kind of keep them engaged, right? Data science actually drives a business, right? You are actually in a driver's seat, if not anything, propelling that business forward. I think if you're in a CEO review, if you're in a CTO review, if you're in like all the C-suite review, there are two people that are must present: a data scientist and a product manager, right? That's the level of authority you actually end up having if you're a really good data scientist in a company, right? And similarly, what do we do at LinkedIn, right? My job at LinkedIn would be like, look at engagement, how many people are applying for a job, are we actually sourcing the right job to the right people, is a recruiter kind of following up, are we showing the right content, is the search actually helping, are people converting, are people connecting, what is the value of connections, right? What is the true north that the business should operate on, right? So for example, there is, I'm sure you've heard of this thing. If you've not heard, this is a great thing, right? Facebook has this magic number, right? If you look at their product, up until you don't connect with 7 friends, they actually don't show you anything at all, right? 7 is the magic number. The minute you actually have 7 friends, you start using Facebook, starts becoming much better for you, right? Similarly, there's a magic number for LinkedIn, there is a magic number for Uber, right? So who's come up with this magic numbers that actually help them build that right product and business, right? Data scientists, right? Who are telling people what should the like button look like, right? Who should we show this ad to, right? What should the screen look like? What should the UI look like? What is the color of the button, right? Who's telling? Do you think the color of the button is decided just based on heuristic? No, the color of the button, like if there is an OK button, right? If there is a submit button and if it has blue color, right? That blue color is actually experimented, right? If you see, some platforms will have learn more, some will have sign up, some will have buy, some will have, other things. How do you have come to realization that this is the keyword that we should have, right? It's using data, it's using experimentation. That's how powerful this seat is, right? So I'm going to wrap this up by saying that, data is not new. Data has existed from a very, very long time, right? The history that we know is from 1935 onwards, right? And the excitement in data is because data actually drives a lot of things. It's front and center for the business. You could do a lot of things with data. It's super valuable for industries, companies, government, political agencies. Everybody is looking at data. And then a data scientist, just to summarize, right, is a very, very key and effective player in the organization's growth, right? Today you will see even a startup, right, they will have engineering and data science opening together, right? A few years back you would see like startups hiring engineers, startup hiring, marketing people, right? Today everybody is just after this, one skill, right? And we spoke about, what is the skill gap that we have today, right? The amount of data that is getting generated and the amount of, lack of resources that we have, right? So, and what are different applications of data science and analytics, what will you be doing when you become a data scientist in a company, right? What are the different applications, and so on and so forth, right? So finally, to leave you guys to think more, is that it's one of the most exciting skill to acquire, one of the most exciting domains to be in for the next 15 to 20 years. Data is just going to explode and everything is going to be super valuable. Every data scientist is going to be super valuable. You're going to be a problem solver and you have the key driver seat in a company. I mean, who doesn't want that, right? So with that, I'll hand this over to Gaurav to kind of take us through the next part of the slide. If we'll take Q. I mean, I'll go through the chat. If you have more questions, I'll kind of like prepare to answer them after Gaurav finishes off. Thank you so much for paying attention, and I hope this was useful. You all got to learn something from it. And if you have more questions, I'm on LinkedIn. You can connect with me if you want to discuss anything. Just feel free to reach out. You can search by the name of Pawan Kumar 91 on LinkedIn, and you should be able to find it. Thank you.
Sure. Thank you, Pawan. So yeah, it was really insightful. I think you perfectly articulated that what it takes to live a life of a data scientist. But just to summarize what Pawan said, you need to be a problem solver. At the end of the day, what is more important is not to be a coder, not to be a statistician, not to be a computer scientist, to be a problem solver, because businesses are looking for solving problems using a proper systematic approach, factual based approach. So if you've gone are the days where we see decisions are made by intuition, so you can make decisions through two methods, right? System one thinking, system two thinking, we all know. Either you use a very intuition based model where you already have some level of information and you want to try, you want to use that to come to a decision, or you can use a data driven decision model, right, where you allow the machines, you allow these algorithms, you allow these techniques to come up with certain insights. And obviously this will be backed by certain parameters, accuracy, precision, which will give you more confidence to trust in that decision, right? So a very logical, rational approach to drive decisions. And in fact, in the modern day organizations, what we see it, uh, organizations are becoming or driving to become data culture, right? They're driving this data culture, data smart. That's a new word which is coming out. How can you be data smart? That is not necessarily limited to a group of data scientists. I think the whole organization is aspiring to become data smart, and there are ways by which we can do it. It's very important to also understand that if you don't come from a programming background, if you don't come from a mathematics background, and so will you be able to adopt these kind of technology to take certain decisions which will be useful for the organization. And I know in regards to that, I think there's a question. I think some of the questions that are in the later stages, there's one question which I wanted Pawan you to answer. So Andrea is asking an interesting question. Actually, we all go with this particular problem. I would really love helpful tips to how to stop ad to share in between your devices. I'm new at this, so she wants a very simple answer on that. Not getting into the technicality of it, but she's interested to know: is there any way you can turn off the ad sharing between devices? Some people are getting overexposed to AI. Sometimes it does wonders, but sometimes it becomes a pain point that you're seeing too much of information, and you may not be really ready to absorb that much of information at that time. So, what's your take on that, Pawan? I think this is a direct question to LinkedIn also, right? Where we see multiple ads popping up, and sometimes algorithms do fail. Those ads may not be relevant at times, and that's the beauty that data science is not all about being God or being about perfect. It uses certain methods. So what's your take on that, Pawan?
Great question, Andrea. Really happy to do a deep dive on this, but at a very, very high level. Of course, we really need to do a deep dive to kind of like help understand. There are actually two things, right, that you could do, right? One is, start using the privacy settings that some of these platforms actually present today. It's becoming a very, very active conversation in some of the big tech giants, right? At least I know I can speak for LinkedIn, right? LinkedIn has a very, very stringent data sharing policy, right? In fact, a data scientist also doesn't have access to all data, right? They don't expose any personal identification or data at LinkedIn, which I'm super glad, and it's one of the most ethical organization that I had the opportunity to work with, and I'm really proud of that. Speaking for Facebook, there are some privacy settings that you can use to kind of like turn off the sharing, right? But in most cases the data is actually not getting shared, right? But what's really happening is there are identifiers, there are cookies that are actually stored in your devices, in your browsers on your phone, that some of these companies have access to. Like for example, Google has access to your search data. Google has access to some of the phone information, right? Google has access to your location information, right? So there are certain degree of data that has been just published out there, which they are using to kind of convert this, right? So in some sense, there's also a very, very active lobby that people and companies have set up now, which are regulating some of these things, right? I'm sure you must have seen, Sundar Pichai was brought into the sorry, what is that? The parliament to kind of like address some of the data related question. So did Mark Zuckerberg. So is Microsoft, so is LinkedIn, and everybody else, right? So there's an active thread going on in terms of how do you safeguard your data, right? There are certain applications that basically let you do that. I think you should just start by using some of those applications. I'll just share them with you offline if you're interested. And second is, while Gaurav mentioned this, right? There is beauty to AI, but of course, sometimes AI is wrong just because of biases, right? One of the things that we are trying to solve at LinkedIn, right, is how do we ensure that AI is fair, right? I mean, I'm not only talking about this ad related business. Just think about, one of the problem with data is the historical bias that the data has. Let me give you an example, right? Say, for example, historically, you would have seen a lot of male candidates getting recruited, right? That's because there were a lot of male candidates applying for a job and getting selected, right? And when you plainly build a model or a predictive model based on historical data, what tends to happen is your machine is also going to learn based on that bias, right, and not accommodate for what's recently been changing, right? So in that sense, what happens is when a recruiter is searching for a candidate, right, because of that bias, you try to push a lot of male candidate upwards, right? So this is a concept that at least in LinkedIn that I'm aware of and I can speak for because I was part of it, is there is a fairness team, right, that they actually call it fair, right? Which is basically trying actively to remove some of these historical biases. Like there is a similar thing that happens in the US. There is this bias historically with some of the cops data, with some of the prison data, right? If you're a black person, right, your algorithms will basically say, and if you're fined for something, your algorithms will say, you're positive or negative, right? But in reality that might not be the case, right? Those are happening only because we are referencing to a data that is already biased, and the machines are not smart, right? Think about it. Machines don't have context. They don't have consciousness, right, to evaluate. Machines are actually learning and improving over a period of time, right? So as data scientists and analysts, it is our responsibility when we are designing some of the solutions to ensure that the model is interpretable, the model doesn't have biases. Even if there is biases, how do you basically upweight it so that we don't have to go through this? And similar experience for ads, right? So a couple of things that you can do is start flagging the ads, right, saying that I don't want to start, I want to stop seeing these ads. And figure out, of course, like in this case, Facebook owns Instagram, Facebook, and WhatsApp. There's very little that we can do because they have access to data for across all three platforms. But there are also applications that share data between some of these, like for example, Google has, because you're running everything on Android, right? So there is a possibility that Google has information to more information than just what you're surfing for, right? So they kind of use some of this
Sure.
in context and start showing. There are ways in which you can turn them off, and see, like, we can chat about it offline and tell you, how what are some of the techniques that you can use to kind of turn this off.
Sure, sure. Thank you, Pawan. So we are running short of time, so we'll take a few questions. But before that, I wanted to there are some questions related to the fact that what should I do to enter into this field, and that's the last section of the of today's webinar. So I just want to walk you through the offerings by LearnXT. So we have a set of we have a suite of degree and diploma programs, and all of these are UGC approved programs. And I can see some questions are related to the fact of differences between each of these programs. We'll spend 5 minutes on that. So one is MBA in data science. So gone are the days where MBA is more of a general management skill, but now people are looking for more specialized skills in MBA, and that's where the inception of MBA in data science. You will have specializations in business analytics and MLAI. This will allow you to achieve two things. One is you will understand some of the business acumen, which is very crucial for any manager role, or any sort of, if you're looking for a leadership role in your organization or in new organizations. Second is adding that technicality to the solution. I think gone are the days again where there is a concept of people's manager or resource manager or delivery managers. I think you need to be super good and have to have a blend of techno-functional roles. You should understand the function. You should have the functional expertise, but it should also be able to give and drive insights within the team to help them to take the technical output decisions. And that's where the MBA Data Science program, it's a great blend of business acumen and data skills, which will allow you to allow you to experience the best of the both worlds. Second is a very technical program for people who want to take a CTO path or want to stick with the technology, get into the architect level roles. They can look for an MSc course in applied data science. And then we have around degree, diploma offerings. One is applied data science PG diploma, there is MLAI. I'll have details around it. So as I said, MBA Data Science is a course focused on business acumen plus data skills. Comes with two different specialization, business analytics and MLAI. You'll also get a 2-month internship with our corporate partners, which will allow you to have real life experience, which can directly go into your profile and talk about the applications, what we go through through it during the course. And believe me, this has 1700 plus hours of live learning. Okay, we are not talking about self-paced recorded content. It's a proper degree program, so you'll have to go through a more comprehensive approach of learning. So this will have 1700 plus hours of live learning over a period of 2 years, with a split of 60% of hands-on and 40% on concepts. You will be exposed to 250 plus assignments and 15 case studies and 280 plus hands-on exercise. So you can understand the rigor of the course for somebody who is really serious to pursue a role in data science and want to use this as their next career choice. You should definitely look for a course like this, MBA in data science. Another course is, as I said, MSc Applied Data Science. If you're working as a programmer, if you're working in IT and doing a lot of heavy duty programming and want to extend some of that experience to data science, predictive modeling, ML and AI, this course would be useful for those candidates. Obviously, you need to have, I would recommend engineers, BTechs to do MBA because that's where they have more focused on. MSc is for people who have 3-year graduation, either you're BCA, BSc. You can opt for an MSc degree. Again, this has being offered in two different modes. There's a full-time classroom mode for people with less than 2 years of experience, just started their career, and there's a weekend hybrid mode for experienced folks. Okay, and you will also get a 3-month internship. Again, 1800 plus hours of live learning, 70% hands-on project, and 30% of concepts. And then similarly, you will have assignments, assessments, and case studies. The PG diploma is a more compressed version. Many people will have this that may not be able to dedicate 2 years of their time. So they can go for a diploma program. I think all the program is incomplete on its own. It doesn't mean that you need to do a degree once you finish the diploma. Every product is complete in its own sense. The only thing you'll not be exposed to too many case studies because it is being covered in 1 year. The core concepts are definitely covered. It will help you to enter into the job role of data scientist. It has around 1000 plus hours of live learning, the split of 70-30 on cases and theoretical classes, and then similar number of assignments, cases, and assessments. The another one is MLAI. People who are again looking to who have some level of understanding and are very new to their career, and they are very I would say very fanatical about the fact of MLAI. They don't want to do a lot of heavy duty programming, want to really build smart models, work on smart solutions. This is the program for you, which will allow you to complete study. Obviously the basics would remain same. You'll go with applied statistics, some of the regression techniques, data exploration, and other stuff, but this will be primarily focused on applications of ML and AI. As Pawan talked about, cognitive computing. You will have computer vision, neural networks, artificial neural networks, and speech recognition. Those kind of solutions you would be building. Again, it's a 12-month program offered in hybrid mode. So it is primarily recommended for working professionals. The career next, if you remember our differentiator where we talk about 100% placement guarantee. So this is a particular service, which we offer it to all our students. It's a very comprehensive. It's not a job portal. It's a career service, right? Which will allow you to achieve 6 things. Career planning will start from self-discovery, personality test, knowing what kind of competencies you had it in the past and what kind of roles you are looking for. And it is more, end-to-end understanding of your, current experience, your future, your aspirations and your competencies. Resume building, another fact, I would say 90% of the time people are getting rejected at level one because they don't write the right thing in their resumes. It's very important that what do you convey it in the resume. It has to be very powerful. It has to be very crisp and oriented with some of the cases what you have worked on. Show your work upfront. We help that to build as a part of this process. Mock interviews will prepare you to really experience the real interviews. It's more of a stimulation what you go through during the course, that 2 year period or 1 year period. The career coaching service will allow you to shortlist job roles what you're looking at. It will also help you to look at the right career path based on your past experience, your educational qualification, and your sort of learning and projects what you have taken during the course. Internship is again is a very powerful tool to showcase your real life experience. Most of these internships are sponsored. You will be able to work with one of the companies, which will allow you to get really see what happens on the floor, right? And most number of times what you see, and that's where the gap is, right? What you study in academia versus what you implement at job, sometimes it turned out to be completely different or entirely different. And there's a very low intersection between these two things. Internship will allow you to increase that intersection point. You will be able to experience, learn at the campus, and on-field internship will allow you to apply those concepts. Job search support, again, that's the end game for everyone, where you'll be able to shortlist the jobs and set up the interviews, and then you can go ahead with the rest of the process. So that's all I wanted to cover as a part of this webinar. Now there are a few questions. Let me take up the first one. Ayush Mehta. Do we really need a computer science, engineering, or statistics background? Anyone with engineering background can work. So look, that's another myth. So Pawan and I were talking offline about it, and we expected this question to come in. So you don't need to have an engineering background or statistics background to become a data scientist, right? In fact, if you go and look at the top data scientists in the country, coincidentally, both Pawan and I, turn out to be engineers, but that's not we are not the right sample size here. But if you look at go and study about the top data scientists in the country, you will find out they come from diverse background. In fact, the top three, top five don't have an engineering background, by the way. And you can see in Analytics India magazine, they keep publishing about the top 10 data scientists in the country. You'll find they come from different background, economics. People have done. Obviously, you'll find computer applications. Some of them have done BA, BCom, and I'm really amazed to see that the acceptance of the diversity is fairly high in data science. I don't see any other industry where acceptance is across disciplines. There's always a need of an MBA or engineering, or if you want to become a scientist, you need to have a PhD and all of that, right? But in data science, the acceptance is fairly high. I think it is very flexible in this way, and it looks for certain skill sets. Some of it are inherited, some of it can be acquired, right? And that's where the real job roles exist, right? So yeah, to answer your question, you don't need to be computer science engineering or statistics background, but if you have it, you have some bit of understanding. But as I said, most of these skills can be acquired, right? The starting points may be different for different people, but that doesn't mean that you can't start at all, right? So you can definitely start. And obviously, some people will start from a programming experience, some people will start from a problem definition stage. Okay, so I hope that answers your question, Ayush. Now, yeah, a lot of applause for you, Pawan. People really loved your session, so I can see that. Thanks for that.
Thank you. And just to add on to what Gaurav was saying,
Arun asking what's the difference? Sure.
hey, Gaurav, if I can
Please
just to
go
give
ahead.
you a data point, real life data point, right? So, in fact, at LinkedIn, we happen to hire at least three, if not more, data scientists who don't have an engineering background, right? If a big company like that can do that, right? Just imagine what are the possibilities, right? So that's a real life
Yeah.
example for you, right? We want to hire based on merit, not based on your background, right? If you're capable of doing the problem, I mean, if you're capable of addressing the problem, if you're capable of, solving analytical problem, right? We don't necessarily need to kind of look at your background. Are you an engineer? Are you a computer science engineer? No, none of that actually matters, right? You have the right credential, you come into an interview, you solve the interview, you have a job, right? That's all it is, right? Yeah.
Right, right. Completely agree with you on this, Pawan. And another myth, I want to take this opportunity to explain this, that data science is all about programming. It's actually not at all about programming, because in my last 10 years of data science, being a data scientist, I have been exposed to multiple tools. I started with SAS in 2010-11, then I moved to R, and then SPSS and all were used as IBM products. Then the Python has picked up, and now we can see suite of tools which are being used in data engineering space. So tools are enablers; they allow you to automate few things, but that doesn't mean that's the core heart and soul of the whole field. In fact, if I have to summarize what's the heart and soul of the data scientist, is going to be data and understanding of the problem. And that's what separates you from a statistician, because you will have, as I said, best of the both worlds. You will understand the business part of it. You'll also understand the science part of it. And there's a typical definition of data science. It's both art and science. Art comes from your domain knowledge. It comes from your business experience. Science is something which we talk about: predictive modeling, machine learning and AI tools. Now, Arun is asking what's the difference between post-graduation diploma in applied data science and MSc in applied data science. So there's a couple of difference. One is a degree program, Arun. MSc is a degree program, and postgraduate is a diploma is a diploma program. It is a MSc degree. It's a two-year degree program. Diploma can be covered in 12 months. In terms of curriculum, also there is some difference. So all MSc is more comprehensive in its way, because we get 2 years of time. We can cover more concepts. But post-graduation diploma is more of a is more of a very compact course which will allow you to study all the basics of analytics, go through different stages of problem solving, data exploration techniques, classification models, as Pawan was speaking about, forecasting models, and then examples and cases related to that. So we'll not be able to cover those 250, 280 cases, as it's a shorter program, but it is meant for somebody who cannot dedicate 2 years or cannot take a full-time course, so looking for only for a part-time. Having said that, MSc is also being offered in part-time mode. But if you are not looking for a degree program, the next best choice for you is a diploma program, right? So it's about the time and investment commitment which you need to make. And more details, we can send it to you offline. You can reach out to us on this number, and the team will explain you on that. Now, Arya is asking roadmap for data science for beginners. So for beginners, I would definitely recommend two things. First, I think you have to get rid of the biases. And thanks to the entire fraternity of data scientists, they created a lot of biasing about the fact that it's a rocket science, it's very magical, and that is why they are getting paid so high. So that it doesn't look very simple to the people that, okay, you're charging me this much of money to do this. So you have to get rid of those biases. It's any other learning what you do. It's a new skill which you can acquire. It is as similar to what you do in acquiring any new skill, right? If you're a programmer, you want to enter into consulting roles, so you have to go through certain steps and processes, right? The similar thing can be deployed in data science learning too. Now, the second thing is, you should have a logical reasoning. So there are, as I said, there are skills which can be acquired, and some of the skills should be inherent, right? You should be comfortable with numbers. If I throw you, an Excel sheet with some 20 records, you should not say, okay, what should I do with that? You should be able to do some basics to it, right? Which you would have gone into your elementary education and your graduation, and if you have a post-graduation there too, right? That is something, you need to be familiar with. Rest all the programs, what I explained, will take care of it. Okay. And it is meant for beginners. So the programs, what I talked about, is not only for people who already have experience in data science. It's also, but also for the people who wants to enter into this field. In fact, that's where the larger segment is. A lot of data scientists may not take a 2-year degree program unless and until they are looking for a job in Google, or a requirement is there to have an MBA or a PhD in data science. but it's meant for people who are standing out and looking at this as their next career choice. What should I do? And I have proposed you a couple of options to take it forward. Nivedan is asking, going forward, what are the jobs highly concentrated, BI or data science? Look, yeah, I think we have charged enough to our clients in the world of BI. I was started my career actually with BI. I was, working in ETL transformations and all. And they have already charged millions and billions of dollars just to tell what had happened, right? BI talks about descriptive analytics, which is what had happened to my business. Now our clients are becoming smarter. Now tell me, hey, I don't just need to know what had happened. You tell me what will happen and how will it happen. That's where the predictive and prescriptive world comes into picture, right? So there will be job roles for BI, but data science is going to be the next skill. Data science is going to be the next big demand, and it is already there, and it is going to go up and up. Even after the COVID, it has scaled up because of the digital transformation. It has also allowed to again store data and do some more level of analysis to build online platforms and develop that digital transformation in the organization. Okay, so there are many questions. Let me quickly go through. Is there any age upper limit to take up this course? As of now, there is not, but yeah, there's a part-time and full-time. For part-time, you need to have a minimum of 2 years of experience, but that's not a mandatory thing, but it's a preferred thing. So this is a question by Naval. So Naval, if you need any more details about the age limit for programs, you can reach out to us on this number and we'll help you that. You don't need any technical background, to be honest. If you have it, well and good. If you don't have it, don't beat yourself up. This can be acquired. That's the point I'm trying to make. Okay. I think Pawan has been answering few questions, so I'm going to skip to that. So Ravi is asking total course fee. So MSc program, the part-time is 1.6 and the full-time is 2.1 lakhs, the degree program for 2 years. MBA is coming with 3 lakhs since it is being offered in 2 different specializations. So there are different fee brackets, but starts from 3 lakhs. So you can actually call to our career counselor on this number. They'll help you to get the detailed fee. It's also listed in our website. You can visit the www.learnxt.com. It will help you to get all the details. Okay, I think I'm gonna skip those questions where Pawan has already has answered. Arun is asking, is there any age bar? I don't see there is any age bar. It's a tricky question. Yeah, so if you're with 20 years of experience, yeah, it will be harder, honestly, because you already have certain set of skills which you have acquired. But again, it's not impossible. But anybody who has 20 years of experience in one field and want to enter into another field, I think it will apply across the board. So anything specific to data science, answer is no. There's no age bar to enter into the field. There are ways which by which we can enter into the field, and that's where the counselor can help you to get more details. Now, Nivedan is asking, are the concepts of DS more important or the tools more important? I think this I've already answered. So there was a saying, a tool, a fool with a tool is still a fool, right? So that's not the whole idea, that you don't need to have, tool experience to become a data scientist, right? It's again more about solving problems, understanding certain stuff, which is very, very crucial for those businesses. There are two kinds of problems that businesses are trying to solve majorly, right? One is top line growth, revenue optimization. Tell me how I can increase my revenue, and at the same time I want to optimize my cost, right? So to increase revenue share, it's an expensive affair, because when you talk about customer acquisition, you can actually control cost, and data science is very, very handy. Will allow you to achieve a lot of operational efficiency and save a lot of dollars at the same time. Naval is asking, I've done an MSc in physics. Now tell me which specialization I have to choose in MBA. So if you already have an MSc in physics, I would, it again depends on what you want to do, Pawan. I think both options are open for you. You can do MSc in applied data science. You can also do an MBA in data science. But it completely depends on what path do you want to take. You want to get into the consulting path where you work as a business manager and also as a part of data science team, or you want to be fairly technical, pick up the data engineering path. You want to develop, become an architect, develop solutions, and be fairly technical about that. So that's the choice which you need to make, but you can do both the programs. BCom, which one is better? So if you've done, again, BCom computers, I would recommend you to go for, for MSc program. You'll also be eligible for MBA program, but I would recommend you for MSc program. Okay, another question is from, is this classroom program? So do we get campus placement from SRM? Yes, as I talked about our CareerNext section, you definitely get a job assistance as a part of our CareerNext platform. There, even in the part-time model, there will be campus immersion where you'll be visiting for 5 days, including Saturday and Sunday, in the campus every semester. So 6-month semester, you will spend 5 days at campus, and first 3 semesters you will have in total 15 days of campus immersion. 4th semester is more about projects and working on the case studies. Okay, I think Pawan has answered few of these questions. Okay, so Naval, the number is already mentioned here. I hope you can see my screen. So that will help you to get more answers, if you have any other questions. Yes, you will also get along with this talk. So it was great speaking to all of you, and huge thanks to you and demystify the entire piece of data science and simplify it for us. So thanks a lot for that. I hope all of you have enjoyed the session. Pawan, any last notes you want to do?
Thanks a lot everyone for attending this session. It would be great if you could take like a screenshot or like a selfie equivalent. I know I miss this offline world. Just for the sake of it, we feel like that connection kind of is broken. If we could, all turn on the camera and then get into a gallery mode. And Gaurav, is it okay if we can take like a screenshot of all the attendants and kind of uh,
Absolutely, that's a great idea. So guys, if you can, so we still have around 21 people. If you guys can open your video, we can do that. And let me put it in the gallery mode.
I think you should stop sharing. Yeah,
Yeah. I'm just doing that.
I guess it'll be really great if everybody can turn on the camera. I mean, if you're not comfortable, that's also okay. But it'll be great.
Let me take a photo from so I can share with you directly. So yeah, thank you guys. It was nice speaking to all of you. Have a great rest of the evening. It's already quite late, and thanks for being with us. Okay, have a good evening. Take care. Good night.
Thank you so much, guys. Have a great day.